Galaxies similar to our Milky Way that formed when the universe was 25% of its current age are spotted by NASA's James Webb Telescope. James Webb spotted galaxies with stellar bars, which are elongated features of stars stretching from the centers of galaxies into their outer disks. These galaxies formed up to 11 billion years ago, 25% of the universe's current age. This means there were galaxies forming stars to what is present in our galaxy. NASA's James Webb Space Telescope spotted galaxies similar to our Milky Way that formed when the universe was only 25% of its current age, with one dating back 11 billion years. These massive collections of gas, dust, and stars are also the first to feature stellar bars, elongated features of stars stretching from the centers of galaxies into their outer disks shortly after the Big Bang occurred 13.7 billion years ago. Stellar bars are present in our galaxy, but this is the first time scientists have seen them in the early universe, a discovery that will require astrophysicists to refine their theories of galaxy evolution. Sharda Joji, professor of astronomy at the University of Texas at Austin, said in a statement, "This discovery of early bars means galaxy evolution models now have a new pathway via bars to accelerate the production of new stars at early epochs." NASA's Hubble Space Telescope previously detected bars, but never at such young epochs. In a Hubble image, one galaxy, EGS 23205, is little more than a disc-shaped smudge, but in the corresponding JWST image taken this past summer, it's a beautiful spiral galaxy with a clear stellar bar. "We are dropping everything else," said Joji. The bars hardly visible in Hubble data just popped out in the JWST image, showing the tremendous power of JWST to see the underlying structure in galaxies. The team identified 6-bar galaxies ranging from 8 billion to 11 billion years old. Yuchen Keiguo, a graduate student who led the analysis, said, "For this study, we are looking at a new regime where no one had used this kind of data or done this kind of quantitative analysis before, so everything is new. It's like going into a forest that nobody has ever gone into." Bars are found in up to 65% of spiral galaxies and affect the motions of stars, dust, and gas. Scientists believe that bars act like a funnel, pulling matter into the bulge from the disk and boosting star formation. Bars also help to grow supermassive black holes in the centers of galaxies by channeling the gas part of the way. Bars solve the supply chain problem in galaxies, Joji said. "Just like we need to bring raw material from the harbor to inland factories that make new products, a bar powerfully transports gas into the central region where the gas is rapidly converted into new stars at a rate typically 10 to 100 times faster than in the rest of the galaxy." Astronomers have believed for many years that our galaxy is home to a stellar bar, though its presence has been inferred indirectly. According to the Spitzer Space Telescope team, the reason bars have not been confirmed in the Milky Way is likely due to our vantage point within the disk of the galaxy. This makes it difficult to accurately determine the size and shape of this bar and surrounding spiral arms, the team shared. The first study to find a stellar bat at the center of our galaxy was released in 2005. The team of astronomers at the University of Wisconsin-Madison used NASA's Spitzer to survey more than 30 million stars in the center of the Milky Way. The orbiting infrared telescope allowed astronomers to see bright stars through clouds of interstellar dust to draw a vivid portrait of the center of the galaxy. Ed Churchwell, who was involved in the project, said, "We're pretty certain of the extent and orientation of this bar because we got more data than anybody else that has ever brought to bear on the problem by a long shot."